Hello guys, and welcome to another video. Today we're going to be looking at an interview question. So typically I'm the cybersecurity lab. I help students with the homework or any other computer related stuff. And a friend of mine worked up to me and asked me this question. She said, you have 9 balls of the same size. 8 of them weigh the same and 1 of them weighs slightly more. How can you find the ball that is different by using a balance and in 2 moves? So this question is fairly easy once you understand it, but if you don't understand it, most people try to solve it in n-1 moves. All right, but the way that we solve it in 2 moves is first we divide the balls into 3 groups. All right, we take the first group and we put it on the scale. If the first 2 groups equal each other, meaning that they're part of the 8 balls that have the same weight, then we take it off and we take the last group and we put it. Definitely the last group is going to have one of the balls that weighs the most. So we take 2 balls from the third group and we put them on the scale. If they're the same size, that means that the last ball is the heaviest weight. Now this is not a scenario. So we take the first 2 groups and we put them on the scale, and one of the groups weighs the largest, right? It weighs more, so the scale is going to tip. So we take the largest group and then we take off 2 balls from the largest, right? And we put them on the scale. If the scale has one of the largest, then the scale is going to tip, so we can just pick the largest. And we can always do this in 2 moves, all right? So let's go ahead and actually look at the code to solve this problem. Exit and close this down. So what I want to do is go ahead here and create a class. I'm going to call this one Max Mable, and spell Mable. Okay, Max Mable .java. All right, so now that we have this, we can start by first getting a list of our marbles. All right, so we need a private static lists. Why does this always give me the so we got, I like this IDE, but it could get frustrating. All right, so we have a list and we want to make that integers. All right, and this is going to be a shuffle list to make it fair. So we're going to shuffle the list every time. Shuffled list off. Let me put off marbles. All right, so next we want to do is we want to keep a list of marbles. So list marbles is going to equal to new array list. Hopefully it imports right, thank God. All right, and then next what we need to do is we need a secure random object. So it's going to equal to new secure random. All right, and not this either, but we can do this here. Do a java.security.secure random, and let's bring this up. All right, so now we can create a for loop to simulate adding the numbers in. So we need 8 numbers of the same weight and 1 that's randomly generated, and we can give a random weight too, but that's not going to be equal to the rest. So what we need to do is just create a variable, call this index equals to 1. Index is less than or equal to 9. Index plus plus. Now you can say that if index mod 9 equal to 0, then you're gonna do list marbles dot add random dot next int, and we want to make a low and high. So I'm going to make this at 10 and the low at 4. So we should get a number between 4 and 13 since the pseudo-random algorithm generates one number less. So we get 9 here. 9 plus 4 should be 13. And if we generate 0, 0 plus 4 should give us 4. Right? Else, then you're going to do list Mable dot add 1. So the rest of them is going to be a width of 1. And then after this, what we want to do is we want to go ahead and shuffle. So we're going to do collections dot shuffle. Okay, let's spell this wrong. Yeah, collections dot shuffle, and we want to shuffle the list marbles. All right, and then we can go ahead and return the list marbles. And we can always test things as we go. So I'm just gonna go ahead and create main here so that we can make sure that everything is going well, so that we don't have to fix a lot of errors at the end. The system.out.println line, and just pass in shuffled list. So this should give us 9 numbers with one of the numbers bigger than the rest, and we can just run this here. And let me see why I'm getting an error. For some reason it might be, I think it might be the import statement. Collections, Java, the secure random. You know what, let me just go ahead and see security. Oh, it's giving me an error based on this, but it's not part of the file. Let me do a manual. Max Mable, list marbles. Oh, make sure that we convert this to passing this as not a raw type. Okay, and let's try this again. Okay, so that works fine now. All right, so we can just run this here and click on here, and we should get the number. One of the numbers is going to be biggest. It's going to be bigger every time, and we can run this again, show that it actually it changes the index location or the position for the biggest number. It's giving me the same spot. Let's see. Oh, there we go. So it's a little higher up. All right. So now that's done. What we need to do is figure out if the values, if the list, right, the sub lists are actually equal to each other or not. So what we need to do is create another method, and this is going to be a private static, and going to be a list of integer. So a list of integer, and we're going to call this one max or no. Okay, so if the numbers equal to each other, we want to return null, all right? And if the numbers are greater than one of the numbers is one of the lists is greater than each other, then we want to go ahead and actually return the greatest list. Okay, so we can use that instead. So what this is going to do is take in two lists. It's going to take in list of integers. I'm going to call this one L1. L1 and list integer, call this one L2. All right, so what we want to do is we want to go ahead and sort. So we want to do collections.sort. We're going to sort L1 and L2. The reason why we're doing this is because instead of, if the numbers are the same in the last index, right, then that means that they are equal to each other, because the only number here that's biggest is the one number that we generate. So we can use that one number that we generate to figure out where the list, if the list is equal or not. All right, hopefully that makes sense. And then what I'm going to do is we're going to start L2. So next what I want to do is you're going to get these sizes. So we're going to say there, let's do final N1, and let's not forget the there here. It's going to be equal to list L1 dot size -1, and final var N2 is equal to list2 dot size -1. Okay. So now what we can do is we can say that if L1 dot get N1 dot compare to, and we can do that with L2 dot get N2, right? If that is equal to 0, then it means that the lists are the same. So what we're going to do here is return null. If it isn't, then what we want to do is we want to return the list L1 or L2. So you're going to say, you're going to return L1 dot get, and then we can pass in N1, and if that is greater than L2 dot get N2, then the largest one is going to be L1, or we return the largest as L2, right? And that's pretty much it for this part here. Next, what we want to do is we want to go ahead and solve the problem. So we're going to create a private static int, because that's what we want to return. And then we're going to return the heaviest. So heaviest found. And then we need the list, the shuffle list that we did earlier. So it's going to be integer list. And this is going to be the weights. Okay. All right. So first, what we need to do is we need to get the subset. So we can say subset 1 is going to equal to. We're going to do weights dot sublist. And we want the first 3 numbers, right? So we're going to go from 0 to 3. All right, and then we need the second list, because remember we need three sublists. Okay, so we're going to do subset 2 is going to equal to weight dot sublist. And this time we want to go from 3 to 6. So we get just 3 numbers. All right. So now what we need is just a simple if statement. So we're going to say that if, and then now what we can do is if we want to see if these two are equal to each other. But first, what we need to do is get the max. So this has the max in there. So what we can do is use the method that we wrote here, which is called max or null. We can use the max or null, and we can pass in subset 1 and subset 2. All right. So now this should give us either the biggest subset between these two, and if they're equal to each other, then it should give us null for this. So now if we check null, we're going to say if max is equal to null. Then we're going to pass in the last set. So you're going to say that max is going to equal, and then we can use the sublist. So we're going to do weight dot sublist, and then we're going to go from 6 to 9. So that's pretty much saying we've already put this on a scale. We've weighed this out. This is what we're doing here. We're weighing this out here, and if these two are equal to each other, then we need to get the last list. All right. If not, then we just use whatever we get here, because this is no longer going to be null. All right. So now we just need some if statement. So we're going to check the first two balls. All right. So we're going to say if max dot get 0, so the first ball, right, dot compare to, and then we do max dot get 1, so compare that to the second ball. If that is equal to 0, right, then we're going to return the last ball. So we're going to return max dot get 2. However, let's say that the first and the second ball, right, the heaviest is one of the first or the second ball, so we need to get another statement for that. So we're gonna say if, you know what, I think it'd be better just to do it the other way. Yeah, might be better. So we can just do return, right? And then here we're going to do max dot get 0. So the value at 0, if that is greater than max dot get 1, then we want to go ahead and return max dot get 0, or we return max dot get 1, and that should be cleaner than what I had. Do max get 1. All right, and this is the complete algorithm to solve this problem. So now all we have to do here is let me just take this out and keep the statement in. All right, so create a var here. This is going to be the marbles. It's going to equal shuffled marbles. And then all we need to do is pass in heaviest found. So do heaviest found, and then pass in, all right, let me change this to weights. All right, and we have a working algorithm. So now every time I run this, you should get the biggest number. So let's run this. And another error. So let's figure out what the error is. Again, I'm going to go ahead and do a manual compilation so that I can see the errors a lot more better. Another error. Let's see. So that's line 27. Okay, so just change this from, what is the capital letter? Oh, right here. Change this from cap L2 to regular L2. I think that should fix it. Let me run this again. Okay, so that works now. So we can just do a compilation here. So click run, and then click on this little thing right here, and it should give you 9. So every time that we run this, it should give us a number that's bigger, that's either 4 or bigger. All right, so that will always find the biggest number. So 11x 6 10 11. So we should never get 1 as a solution for this, an answer for this problem. All right, guys, this will be it for this problem. I hope you guys enjoyed it. I know I'm taking a little bit more time to write this. For some reason, I'm not the fastest typer. I grew up in Africa, and I didn't see my first computer until I was about 14. So bear in mind with me. I'll see you guys on the next tutorial. Bye bye.